Everyone, welcome back to another exciting day of mathematics. Warm-up number 90 should come up on your screen as soon as you log in. Let's get started, please. You do need a calculator, so get a calculator. Send a gopher for one. Copy and go. Warm-up 90. And just a reminder, this is being recorded so that you guys can use this later on if you need to revisit. Today we are moving on, so everybody go like this. Bear with me because we're about to head in a awesome direction. I like that. All right, Mario, mean. 15. Hands if you got 15. It's about right. All right, Mario, pass someone for the standard deviation. Standard deviation. Max, what'd you get? Approximately 9.3. Hands if you got something like that. Looks about right. So I'm going to do 24.3 or 5.7. Is that correct? Yeah, right. All right. However, we need a z-score for number 8 to see where it falls in the bell curve. Pass someone, Max, z-score. Back to Mario. Mario, z-score for 8. Artie, what'd you get? Negative point what? 75. Hands if you got something like that. Looks about right. So our mean is here. Negative 0.75 is close to the negative 1. And looks about right. And what does that mean, everyone? That the number 8, it's still within the what? Within the norm. Yes, that is correct. All right. All right, last but not least, compute 11 factorial divided by 9 factorial. Tell you what you got. Then Brandon's going to pass them one. 11 factorial divided by 9 factorial. Brandon, pass them one. Who? Mel, what you get? 110. Hands if you got that. That is correct. Let me illustrate. We got factorial 11 over 9 factorial. So what is factorial 11? 11 times 10 times 9, yada, yada, yada. However, in order to match the denominator, I'm just going to leave instead of writing times 8, times 7, times 6, all the way to 1, I'm going to leave it as a factorial. So the denominator is 9 factorial, and why do I do that? So like that we can get a giant 1, and that leaves us with 11 times 10, which is 110. All right, send that in, please. And copy the agenda. Warm-up number 90. Complete. Today we're moving on to permutation rule. And tonight's home plate, we have 3 problems only. Hopefully we can complete those here before we leave. And adjourn. How's your weekend, by the way? Pretty good, yeah? All right, yeah, well rested. Same here. Like my back feels better. I think it's also because it's not as cold throughout the day, so I'm not getting as stiff from my lower back. So I'm good. Rocking and rolling. Yeah, we got this. And we had a pop party on Friday. Let's go. For those of you that were absent, make sure you come in during the advisory. Take that pop party because I'm telling you, grades are coming up pretty quick. So some of y'all are messing around too much. So pick up the pace, people. All right, let me send that to your screen. And then copy the code to access the home plate. There it is, 2LJSR. 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 All right? So that's going to give you access to 3 of the home plate problems. All right, get a Cornell note ready, please. Our objective for today, I can identify and compute problems with the permutation rule. Problems with a permutation rule. I can identify and compute problems with a permutation rule. Get a Cornell note going? All right, thank you for sharing. So, permutation, I can identify and compute problems with permutation rule. So, before I get started with the rule, let me just go back to make sure we know where we're at. We know the definition for probability. We know the three different probabilities, right? Yeah. By now we're experts, so there they are. And from there I said we got into counting rules, and then we started with the fundamental counting rule. We went, now we're today in permutation, and where we're headed is combination. So hopefully by Wednesday we'll complete this section, okay? So here it goes. Look up to the screen. So as you know, I've been sharing throughout the year a little bit about myself. I give you sometimes a look into my brain from time to time. Let me give you another one. Here goes. You already know, and I think I've mentioned this before, anywhere I go, I think of numbers. Why that is, I have no idea. Like one time, my wife and I, we went to the movies. We're in the movies, and then in the movie, it was an action movie, and there was a pursuit, and they were on the freeway. My brain got a glimpse of the sign on the freeway, and then where they got off on the freeway, and then the speedometer in the vehicle. So when I saw all that, my brain computed the amount of time it took them to get on the freeway and get off the freeway in minutes, even though it took like 20 seconds on the movie. And I told my wife, hey, that should have taken 3 minutes. She's like, what? To get off the freeway because they were going at such speed. And then she's like, wow. You know what I'm saying? Anyway, so same thing sometimes when I open some of my favorite chocolates. Like sometimes what I do, I empty the bag and I count the chocolates. Does anybody do something like that? All right, good. So with time, I came to the conclusion that one of these baggies of chocolates has an average of 21 little chocolates in there. Good to know, right? You're looking at me like, wow, Mr. Q. Well, it is what it is. So anyways, if I was to ask you to get all the chocolates out of a little baggie and count how many colors of each, you would do that, recorded, right? And then I would ask you, what is the probability of getting a blue and a green? Do we know how to do that? Yes, it's the fundamental counting rule. Is that correct? You would count how many green, how many blue, multiply them, and that's our answer. However, what if I say, well, I just want us to use blue, green, and red out of all those colors. And I only want those 3 colors. And I ask you, how many different combinations can I do out of all those chocolates for those 3 colors? Well, that is what we call, guys, a permutation. Write this down, please. What is a permutation? Well, a permutation is an arrangement of n objects in a specific order. A permutation is an arrangement of n objects in a specific order. So, being that the bag has different colored chocolates, it's got yellow, orange, green, blue, red, and brown, but I only wanted 3 of them, that is being specific. I only want those colors specifically. So therefore, that's what we call a permutation. So, you wrote that down on your notes. So with that comes a rule. Write this rule down. N of P of R equals n factorial over n minus r factorial. And that's going to be our permutation rule, and I'll elaborate more on that. Copy that really quick. Mm-hmm. Hmm. Tell your neighbor what n represents. Then Maximus will enlighten us. What does n represent? We've been using this n forever. What does n represent? Maximus. How many? Or the total number of objects. That is correct. Total number. However, what does R represent? R represents the specific number of objects. Yeah? So let's say I showed you again the little baggie of M&Ms. Remind your neighbor how many total number of chocolates are average in each baggie. Did I say? 21. Okay. Don't copy that. This is just so that you can think about it. And then the different colors in the baggie are red, green, blue, orange, yellow, and brown. However, which colors did I say I wanted to use specifically? Red, green, and blue. So, think about this. What number should I use for N? And what number should I use for R? Talk it over your neighbor. What number should I use for N? And what number should I use for R? Talk it over your neighbor. One number for N, one number for R. All right. Looks like Austin's got it. Austin T, what number should I use for N? $21, because that's the total number of chocolates. That is correct. However, what number should I use for R? Aleshka. Woo! Let's go. Aleshka. So how many different colors am I choosing? 3. Therefore, instead of R, what am I going to write? 3. Man, you guys are focused, so focused and paying attention, not even typing anything on your screens or looking at your cell phones. My goodness. Copy this problem on your paper, please. Example number 1. And it reads, the advertising director of a television show has 3 ads to use on the program. If she selects one of them for the opening of the show, one for the middle of the show, and one for the ending of the show, how many possible ways can be accomplished? Copy that completely, please. That you can have it in your notes. All right, let's do this one together. Here we go. Start off with our formula, permutation formula, N of R, and that is N factorial over N minus R factorial. All right, so here goes. It says, the advertising director of a television show has how many ads? 7. Tell your neighbor where that one goes in our formula. Where does that go in our formula? All right, where does that one go? Austin T. N, very good. So we got 7. 7, 7. So, what should I write for R? Tell your neighbor, please, and then Austin's going to enlighten us. What should I write for R? What do I write for R? Well, let's pass it to Aleshka. Aleshka, Art. 3, that is correct, because there's how many adds? 1, 2, 3 adds. All right, so therefore, 7 factorial is 7 times, well, I'm just going to write it out first. 7 factorial over 7 minus 3 is 4 factorial. So that is 7 times 5 times 4 factorial over 4 factorial. Before we move on, tell your neighbor why I wrote this like that. Why did I write that like that? Oh, sorry. I skipped the number, right? Yeah, I did that to see if you guys were paying attention. 7 times 6 times 5 times 4 factorial. All right, why do I do this? Lulu. Why don't I write it as 4 times 3 times 2 times 1 all the way? It's too long and it saves us time just by identifying the bottom one, yeah? So there's a giant 1. So that leaves us with 7 times 6 times 5, that's 210 different ways of arranging that. All right? Send me your notes, please, on the screen. For this one, you don't have to copy the problem. Start with a formula, and it reads, a school music director can select 2 musical plays to present next year. One will be presented in the fall, one will be presented in the spring. If she has 9 to pick from, how many different possibilities are there? So use the screen to underline stuff, label stuff, and on your paper start with a formula. Substitute values and find me the different possibilities. Go. All right, looks like everybody's done. Cole! All right. He's going to get us started with our formula. All right, Cole, what goes where? Give us numbers. What is it? He passes it back to you. All right, so Cole, what goes where? What is N? What is it? 9. Very good. And what is R? 2. Hands if you got that. Yeah, so we got 9 factorial over 7 factorial. So you should have written 9 times 8 times 7 factorial over 7 factorial. This is a giant 1, so that leaves us with how many different ways? 72. Hands if you got that. All right, send me that on the screen, please. Let's go to number 4. Number 4, how many different ways can a city health department inspector visit 5 restaurants in a city with 10 restaurants? So start with a formula, substitute values, and find me that. Go. All right, walk us through this one. What have we called on today? How about Austin? T. Let's go, Austin. Permutation rule, and R equals N factorial over N minus R factorial. So then we write ten factorial over 5 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial. So this gives us, is it 30? I can barely see with some of your pictures. Bah! Is it 302,000? Yes? What is it? Oh, 30,240. 240. Hands, if you got something like that? From 1 to 5, I'll confirm you with permutation. We got it, right? All right. So I'm going to stop right there, and I'm going to give you guys a head start with the home plate, which is on the screen. Those of you that are following on YouTube, make sure you get some practice in, and we'll continue with this tomorrow. Bye.